Okay. Hi. Thank you all for being here. Yeah, as I said, I'm Bastian Blössel, and I'm currently at Trinity College Dublin, where I work a bit with vehicular networking. And some of these vehicles use Wi-Fi or Wi-Fi-like technology to communicate with each other. So I looked a bit into these topics, and also using software-defined radio as one of the main tools for my research. So I have a computer science background, so I don't know much about all this fancy coding stuff. So what I usually do is I build some out-of-tree modules with GNU Radio, and usually they implement some particular technologies. So I, for example, have a GNU Radio wireless LAN transceiver, or I also have a Zigbee transceiver, or 802.15.4 actually, because Zigbee is just a brand name for the whole stack. So if you are interested in this stuff, there's a website where you at least have some pointers to more information, so what it can do. And yeah, so actually this whole talk was a bit motivated because I had these different tools for digital communications, and then people were often asking me like, okay, how do I now use it, or what can I do with it? Because GNU Radio usually focuses on the physical layer part of the game. And so people wanted to see how an external application can use GNU Radio from the outside to send data or do some security related stuff or all that kind of things. So these questions about how to interact with GNU Radio came a bit up also on GitHub. And so I thought I give a bit of so the goal is to give a bit of an overview about what you can do with GNU Radio. So, and all these examples, they should, so as I said, I just talk about how to interact with GNU Radio. And it's pretty independent, actually, if it's now a Zigbee transceiver or a Wi-Fi transceiver or Bluetooth or LoRa or whatever, it's more like the interface between GNU Radio and the outside world that I want to focus on. Yeah, so this is the base for, so Zigbee is the base for these technologies, but that's not so important. This is just some buzzwords, because I have the feeling that not a lot of people know what 802.15.4 is, but a lot of people heard about Zigbee, for example. Okay, and something that I put in, because I have seen that now the Pluto is handed out, and there are a lot of people now looking into the topic, is if you want to try GNU Radio, or if you want to try my modules or whatever, then what I did is I worked on a virtual machine image for GNU Radio that I pre-configured, and I, for example, used it a lot in workshops or at university, because it's pretty cool to get started. So if you now have a device and you just want to play around with GNU Radio, or actually with a lot of SDR applications, you can download the virtual machine and just use it. And yeah, it comes with a lot of stuff pre-installed. So there is GNU Radio, there is TQRX, which is a very nice, also GNU Radio-based decoder, for example, for FM, AM, or also FM RDS. So some modes where you can use your SDR, or you have the spectrum analyzer Phosphor, which is very popular, where all these nice images are from, where you can just scroll through the spectrum, see different technologies. Or you have InSpectrum, where you can, for example, use for reverse engineering and stuff, and a link to the GNU Radio wiki. So I think if you, for example, don't have a Linux system or just want to start something and play with it, then that might be an interesting option. What I, for example, so currently it comes with RTL, SDR, UHD, and HackRF drivers pre-installed, because that's the devices that I had access to. But now, since I heard I get a Pluto, it will support Pluto from next week. And then you hopefully can just, so also, for example, for UHD, everything is downloaded, so you don't even need internet and stuff like that. So, and then this is how it looks like when it's running, and it comes also with a bit of development environment. So, for example, you have editors, compilers, and everything. It uses PyBombs. Everything is installed, so even the objects are still in there. So you can go change something, and should be pretty quick to recompile. One thing that I think is particularly interesting is it uses kind of a stage build with Pucker. So Pucker is just a tool that lets you kind of programmatically create a virtual machine. And what I did is you start basically from scratch. I start Ubuntu based, but then I tell how everything should be installed. So it's kind of a bit opinionated. You know, you've seen I've used GNOME, for example. So you start with Ubuntu. Then I have another layer which uses the virtual machine, the Ubuntu one, and just installs the SDR apps. And this is basically what you can download. But the cool thing is, for example, if you are working at university or if you want to give a course or if you are interested in a particular technology that I didn't cover, is that you can just add another layer on top of it and use this as the base image and, for example, only install now some amateur radio software. Or if you are at university and giving a course, you can just use this as a base and rebrand it and maybe so have another desktop image, or, for example, add a link to the university course so that the students has to click there and gets all the instructions and stuff like that. And yeah, that's a bit the idea. And then when you have all these kind of environments set up, and hopefully then it's easy to use because it's just importing a virtual machine appliance and start it up. Then what I'm planning to do, but this is just currently only a placeholder, is when 3.8 is out, I thought like having some tutorials out there which uses the virtual machine, and then there are supposed to be some small modules, something like how do I do a replay attack, how do I do decode FM, for example, so that you have some instructions that fit to this environment with this. But I don't know how far I will get with them. At least I plan to kind of do some of this stuff that I did as workshops, also as modules there, and based on the VM image, so that you can really just follow through it in the very same environment without going through a lot of hassles. Okay, so when you have this virtual machine or whatever, okay, we can actually go back to the initial topic. It's an easy way to play, for example, with some digital technologies. And what you get when you install GNU Radio and, for example, my out of tree modules is you usually get mainly the PHY. So I usually always say you only get a physical layer. And then usually there's also a MAC block. So for example, I have a Wi-Fi block that is called a MAC. And this is where people get a bit irritated because it's not doing any CSMA and stuff like that, because that wouldn't work really well out in GNU Radio on a normal PC, because this is where you have to have very strict timings, where you have to sense the channel and access that. So this is not going to happen. Usually the MAC, in my case and in other modules, is usually only that you add the bare minimum, a header to it, so that another Wi-Fi card then sees this as a regular Wi-Fi data frame, for example, and decodes it. So basically this is what the GNU Radio module is doing. So it just is the main contribution is the PHY and not the MAC. So then people wonder, okay, what can I do with it? Because it says Wi-Fi transceiver, and then they ask me, okay, and how can I send a Wi-Fi beacon? And I said, it's not really connected to the network stack. So the question is, what can you do? And I hope in the talk I have some, let's say, ideas of how you can interface GNU Radio, not only for this Wi-Fi stuff. So how can you send data? How can I interact with with another commercial device, for example? Okay, and so this is what you get when you have the Wi-Fi transceiver view downloaded. You have the physical layer. This is actually where all the interesting stuff happens about signal processing. But so this is what this talk is not really focusing on. In this case, I have the PHY just connected to itself. So it's a loopback interface. It just sends frames and then decodes it itself, for example. And this is the MAC block where I just mentioned, which doesn't have anything to do with CSMA. It's just adding a static constant header that I put here, so you can say, okay, it's a Wi-Fi data frame for this BSS with this source and this destination MAC. And because the GNU Radio example is supposed to be self-contained, just what I did is I just generate some hello world string messages, and then they get wrapped in a Wi-Fi frame. So this is what's happening there. So if you would look in Wireshark, and I hope we do this later a bit, you will only see, okay, so the physical header is extracted by the wireless LAN card, so we don't see that. Actually, the physical layer header is just tells the receiver, hey, there are 500 bytes following, and they are encoded with QPSK 1/2 or something like that. So, and this is the MAC header, which is just a MAC data frame, and then there's the string hello world in there. So this is what you get in there. And then here I feed it to Wireshark just so that we can easily see what's happening with the frames. Here I have a short video about supposed to give an idea of how this looks. And hopefully, so if everything works, I'm a bit worried about my CPU, if we can send wireless Wi-Fi frames, but we'll see out in the demo later. So what's happening here is that you start it up, and then it's just constantly sending Wi-Fi frames with hello world in there. So you can decode them with Wireshark. They are valid frames. But here's the question, okay, now I have some static setup, and that is not really helpful. Okay, it's an example in GNU Radio, but now, okay, where to go from here? And one of the things you could, for example, do, which is an easy extension to that, is you cannot say, okay, I have a static message in there, but you can use the GNU Radio socket PDU block, which opens a network socket for you. And this is then kind of your gateway into GNU Radio. So you can have, for example, any external application that sends UDP packets there, and whatever is in the UDP packet then gets wrapped in a Wi-Fi frame and sent out through your SDR, for example. So this is, for example, it can be a bit interactive. What you can, for example, do, I don't know if maybe you already heard about Netcat, which is something, it's a console program that opens just where you can just type something, and each line is then sent as a UDP frame. So for example, if you're into amateur radio, let's say, and you have, let's say, RTTI physical layer and want to just type some text and send that out through your radio, then this would, for example, be the easiest interface. Just connect to GNU Radio with your program, and then every line you type is then forwarded into the flow graph and could be sent out. So this is one of the easiest way to connect. Or here on the bottom I have an example in Python. So the only thing is just to show you that it is really, really easy to kind of set something up and then have something that you can do programmatically. Because if you're in Python world and know how to get in and out of GNU Radio, then you can do all your external logic from somewhere else and create your frames, see what you received, and so on and so forth. So this is a simple example. I also have this here as a video so that you might have an idea of how this looks. Again, here it's not really interesting that it's Wi-Fi. It's just any physical layer where you can that you can interface. And here at the bottom now, I can type hello world. So on 2 lines. So for every, it created a Wi-Fi frame, and then the payload is hello and world. And here on the bottom, I just have a Python script that's just iterating and sending again stuff. So this is already, I guess, quite nice to extend GNU Radio with something, connect something external to it. Then I have some other ideas, so it's getting a bit more complex, because the first thing that people think about when we do networking, okay, we want to connect to the network stack, so the TCP/IP stack of Linux, for example, and that's also supported by GNU Radio. There was this old script like TunnelPy, I think it was called, that I only heard bad things about. But now there's this nice Tantep PDU block, and with this, it's really easy to connect to the Linux network stack. You need a bit of script. I have that as part of my Wi-Fi module, because you need some commands, okay, to set up IP and stuff like that. But it's really doable. So here, what it's doing, it's again just getting some. So I didn't tell you about a TAP devices. A TAP device is just a virtual Wi-Fi interface. So it looks like it would be just an Ethernet card to the PC, and it feeds data in there, but you can then get them in user space. So basically, I also have a very short example from that one. So for example, if you connect, if you use the ping command will send this ICMP packet to your virtual network device, and the virtual network device is connected into GNU Radio with this TimTab block. And then here I'm pinging something, and then you can see that these ping ICMP packets get through the Wi-Fi transceiver and then can be decoded with Wireshark. So here it's loop back, but over the air it will just work the very same way. So this there's no kind of simplification or shortcut in there. It's really kind of then sending out a valid ICMP request, for example. So that's already a bit more complicated, but you also get a lot of benefit, because if you have IP, then you can do basically everything. Okay, so the next stage in it's getting complex is something that I wanted to include because I think it's very interesting, but this is kind of a Wi-Fi thing only. So when you look at the Linux kernel, then it looks roughly like that. You have your user space application like your browser. It's sending data through the network stack, and then if you have a Wi-Fi device, then you have for Wi-Fi the MAC layer and a configuration layer, like in which Wi-Fi network am I, and then they interface with the driver, and then the driver uses the card to send it out, basically. So this is what's happening with a real Wi-Fi card in your laptop. Now, what you could do is you could use a virtual Wi-Fi interface, and this is something that the Linux kernel already includes because it's called hardware SIM module, because when they implemented the wireless access points, so host APT, for example, they had a virtual interface that really shows up in your PC as a Wi-Fi card. So you can set channels, you can open access point, all that kind of stuff. And this is then rather easy, or hopefully, because to extend so that the virtual Wi-Fi device is now not just looping back, but just uses GNU Radio, and then you could have GNU Radio connected to this. So there was a guy who was doing that, but then unfortunately he had like some issues with open source licensing and whatever, so the implementation that's already there cannot be shared or whatever. So yeah, it's a bit unfortunate. So then with this configuration, I just wanted to add it. I don't know if it's so interesting, but it's really nice. So you see it, actually the SDR could be integrated really nicely as a real Wi-Fi device in that case. Okay, so then there was another thing that was also mentioned came up in a Git commit, because usually what I knew some months ago is that when you want to create some MAC headers, for example, this is a really tedious and annoying process. And here I just have an example that shows you that the way you don't want to do anything is like if you just, for example, in this case, it's just a simple Ethernet frame. When you want to create it in Python, it's already complicated. You have to look up the exact patterns and bits and have to care about network byte order and all that kind of stuff. So this is really something annoying. And this is also the case why I have the MAC block only as one static frame that I once programmed, and it's put just in front of every packet and don't do anything more, because implementing, for example, wireless LAN headers, like everything like the management frames, beacon frames, DAuth frames, QoS frames, and all that kind of stuff, they would have to do a lot of these complicated stuff, and that's why I didn't look into this any further. But some guy then asked, hey, can I connect Scapy to your wireless LAN transceiver, for example? And this is actually, to be honest, I didn't know about it, so I also had to look it up. And it turns out, so Scapy is a really nice library that one thing it can do particularly well is like crafting packets. It's like a bit domain-specific language that allows you to just create all types of network packets very easily. And I thought the easiest way to look at this is in an example. For example, we have now an Ethernet frame, and we just set some of the values we want, and then this would be the whole Ethernet frame which was there in this complicated struct earlier. And then you could, for example, add an IP on top of that, and followed by UDP, and the payload for UDP is hello world. So then you have your whole packet in there, and this is just one line of code basically. So this simplifies a lot. And for example, I have this example a bit more in detail. It also shows advanced features that we don't really need, but it shows you that how comprehensive it is. Like, for example, here we have the destination are two things, so it will create one IP frame to GNU Radio, one IP frame to libvolg. Here we have something in parentheses, which means it's kind of creating a frame with TTL1, TTL2, TTL3, and so on and so forth. And then it basically does everything for you. And I think this is really nice, because what it means is that instead of sending something through the UDP port, just some data payload, you can have kind of a one-liner and create, for example, also Wi-Fi or Zigbee frames, and then send really more complicated frames very easily out through the radio. And one question here is, why do you want to do that? I mean, one reason for this is because we can, and the other is it has some minor advantages because, so let's say you already have a Wi-Fi card, so you can send out anything with your Wi-Fi card. So that's not the problem. But depending on what you want to do, I've seen that some drivers then start to mangle with the frames, or if you want to send some invalid frames on purpose, let's say, then some drivers try to fix something for you. Or if you want to, for example, do some timestamping in the driver and stuff like that. And this is something you get around by using an SDR, because the SDR doesn't know about anything, the physical layer doesn't know about this stuff. And it will just send out the frame guaranteed as it is, so it won't touch it or anything. So this is one of the advantages, I think. And another one is, as I said, for example, wireless LAN is also used for vehicular networking, and then there is a bit harder to get a prototype for this technology because it has a different bandwidth and sending on a different channel. And then you can pay a lot of money, or you can use, for example, the SDR. With the SDR, you can tune wherever with any bandwidth you want. So this is, for example, one reason. And then you can also do with Zigbee. I also think that it's pretty accessible doing it with a software-defined radio. Yeah, and so it's in that case really easier in my opinion. Also, if you already have an SDR, and most of you now have an SDR, then you can just use it and play a bit with Zigbee devices, because then it doesn't cost you anything. Because, for example, some Killer Bee or whatever alternatives are there, some USB devices for the PC, they cost some of them at least cost quite some money. Okay, so how does that look like? So we got rid of this strange MAC block and now can feed something in the Wi-Fi receiver directly, for example. And then we would connect Scapy here. It sends a valid Wi-Fi frame through UDP, and then we can send it out. So to give you just some ideas of stuff you could do is, you have a one-liner that gives you a Wi-Fi beacon frame with a certain SSID, so that is broadcasting. Or something else you can do is you can fuzz some packets, and fuzzing just means that you just fill the data in randomly, basically, and then you can see if the driver reacts to packets that are not standard compliant or just unusual or whatever, and can see whether it crashes, whether it works or whatever. So if you want to, for example, fuzz this beacon, you just wrap it in fuzz, and for every parameter that's not explicitly set by you, it will then just insert whatever. Another thing is for deauth. This was the guy who was asking on GitHub. He wanted to deauthenticate some wireless LAN devices, so you can create a deauthentication frame. For example, it's also just a one-liner. And other one that's fortunately also supported by Scapy is if you have, for example, Zigbee devices. In my case, I have to have one of these devices at home, the smart meter. And it also has Zigbee, so you can, for example, so this is just a sniff of what the device was communicating. And then the cool thing here is, okay, I have some sample data, I know its PAN ID and its rough configuration, and then I can just create some .15.4 frames myself and send them out through the SDR and see how the device reacts. And since I already got the dump, I can, for example, fill in the destination PAN ID, which is something like the SSID of Wi-Fi, or I can also fuzz the device and stuff like that. And now I'm running a bit out of time, but maybe it works fast is. So here that's the virtual machine that I was talking about. Oh no, it got no. No, it's freezing. Is my whole laptop freezing? No. No. Very sad. Okay. Yeah, so actually what I wanted to show is that the live demo with sending some frames. What's going on here? Yeah, VirtualBox doesn't like. Yeah, I'm sorry. So yeah, what I was actually wanted to show is just this in live, where I have the script and can send it with the HackRF to the Wi-Fi kite and monitor mode and see that everything looks also like it's supposed to be over the air. and that really is kind of this two lines basically are enough to really then send valid Zigbee frames with GNU Radio, send valid Wi-Fi frames, fuzzing Wi-Fi, fuzzing Zigbee, and this kind of stuff. But yeah, I think
just the time for extra questions.
Yeah. So then okay, yeah, then Landis ask questions.
Yeah, so we have time for questions.
Do you have any questions? Yeah.
Regarding your VirtualBox image or your whole stuff where you put your phosphor and GR stuff on, do you have a recommendation what kind of resources you need and what kind of USB hardware your laptop should have?
So the thing is with VirtualBox, you need an extension back for USB, but then you get USB 2, 3 that works really well for me. So I didn't have any problems with connecting a B210 through VirtualBox.
So USB controller is not a problem?
No, for me, I don't have a big sample size. I just have 3 devices, and for them it worked. So I can't tell more. But yeah, and then with hardware, it's just about installing more. So because GNU Radio has this pipebombs installer, it's just about adding new hardware drivers. For example, for the Pluto.
And then, would you recommend that for pen testing?
Yeah.
That's what you showed with Scapy.
Yeah. So I think some people want to use it for pen testing. So, for example, for the Zigbee, I think it's quite interesting because there is not too much hardware going around. I mean, there is some Zigbee USB devices, for example, that you can use, but I think it's really pretty easy, or I found it easier to do with the SDR. I mean, I ordered a Zigbee device. I have to see how it works. And yeah, and then it has some minor benefits depending on what you want to do. So sometimes, as I said, wireless LAN driver kind of touches the frames, does something to it, but you get that to the drawback with lots of complex. It's much more complex to do it with the SDR than if you just use AirCrack or whatever to do it with the wireless LAN chip. So it's more complicated. Yeah.
We need to switch over. So thank you very much.
Thanks. Ich will uns hin.